Welcome to your journey to learn Python, the programming language of the future. This video is going to be useful not only for the beginners who don't have a prior experience or an exposure to programming, but it is going to help those who know other programming languages such as C or C++ or maybe Java, because it will help them learn Python, which is the programming language of the future, because Python is really much easier compared to other programming languages, and it can help us implement many things in a way which will make our code much shorter. It will make our code much appealing, and in many ways it has some great built-in packages which will help us achieve our job much easily. So first we need to download a distribution which consists of various packages like NumPy, SciPy, and others, uh, which will help us in our computation, basic programming, complex manipulations, and so on. So first we are going to download a collection of these packages, and one such great distribution is the Anaconda distribution, which we can download from this link you can see up here, anaconda.com/download. Here you can download the appropriate version of Anaconda based on your operating system, either if you are using Windows, Macintosh, or a Linux version. So after you have downloaded Anaconda, you are just ready to move into the world of Python. First, we need to launch an integrated development environment or an IDE where we can push in all our Python code and check how it's going on. So first you can launch our IDE, which this Anaconda distribution includes, which is known as Spider, Spyder. You can just search for Spider from your start menu and you can launch it up. I have already launched Spider for the convenience. So here we are. Here is the Spider. So this pane on the right, IPython console, it's the integrated development environment's kernel. Here you can directly interact with the kernel and you can like just type in any code you want and it will show up the results instantly. And this pane on the left hand side, it's called the script window, where you can type in a script and you can just save the script for future use, and you can run it using the run button down here. So first, to begin with, if you don't have a prior experience to programming, the best way to learn so will be to see how programming can help us perform just simple calculations. Because actually what's programming? It's like we are performing simple binary calculations in the computer's memory or the control unit. So just we can see that if we type in just any piece of code, say you type in 2 plus 2 in the kernel, it will give you 4. Now you this is the plus sign is known as the arithmetic operator. It's an arithmetic operator. There are various arithmetic operators: plus, minus, multiplication, division, exponentiation, which means raised to the power of something, and the modulus operator. I will show you each of the operator one by one. So the plus operator, 25 plus 100, it gives us 125. Now if you want to see the minus operator, 100 minus this 53, 47. Next, the multiplication operator, 1008 times 25, 25,200. Right, great. Division operator, 150 divided by 25, 6. Then we will see the exponentiation, in which we can raise anything to a power. Now suppose you want to calculate the cube of a number, say 2 cube. So just 2, this double star, it shows the exponentiation, and 3, 2 raised to the power 3, it gives us 8. Really nice. Now 5 to the power 5, 3125. This is the exponentiation operator, one of the class of arithmetic operators. And finally, we have the last arithmetic operator, which is the modulus operator. It gives us the remainder when a number a is divided by another number b. Now suppose we have a number a which is 25 and we divide it by another number b, say, which is 5. So just give the modulus operator, which is the percentage sign, 25 percentage 5. What's the remainder when 25 is divided by 5? Clearly the remainder is 0. So this operator gives us the remainder when a number is divided by another number. So this was the class of arithmetic operators we had in Python. Now the interesting part comes. In Python we can display things, we can take input from the user, we can give output to the user, we can write to a variable, and we can just like clearly we can make a nice program or an algorithm based on the merging of these features we have in Python. So first I will show you how to display things in Python. There is a function, inbuilt function in Python, which is known as the print function, and it displays the output to the user. Now if I type print hello world, here we are, it displays hello world in the kernel. Now another important thing, we can take an input from the user, but when we take an input from the user, we should be able to store it in a variable so that we can use it in the near future. And a variable is a partition of the computer's memory where we can store data. The data can be numbers, it can be boolean characters, ones and zeros, it can be integers, it can be floating point distributions. Float means a decimal, there is a decimal after the point in the number. And it can be even a string. A string is a collection of characters, like you can see hello world. This hello world is a string. We will learn more about such types of the variables in the later part of this video. So first let us take an input from a user. Suppose we want to calculate the area of a rectangle. Okay, so what's the area of a rectangle? It's length times breadth, length into breadth. So let us take the length from the user. Length is equal to, there is a function input which allow us to take an input from the user. Length is equal to input. Here you can just type enter the length of the rectangle. But wait, this input function gives us the provision to take an input only a string. And if we want to take an input of a length, but you know the length will be either an integer or a decimal point, like float. So first we need to cast it. Casting means conversion of the variable from one type to another. So length will be an integer, so write here int and enclose it in the brackets because int is a casting function here. So it prompts us for the length of the rectangle. Suppose we say it's 51. Okay, now we need to take an input of the breadth of the rectangle. Breadth is equal to int times, so breadth is equal to, we will need to cast it int input function for taking the input. Just enter the breadth of the rectangle. Nice, so it asks us for the breadth of the rectangle. Say the breadth is 10. Okay, so now we have our length and breadth stored in two distinguished variables. So now we can calculate the area of the rectangle. So area is equal to length into breadth. Now if we want to print out our area, just call the print function. Area of rectangle is, we can use the plus operator, which happens to be the concatenation operator, to combine a result with the string, because we cannot combine one type with another type. We can combine a string with a string, an integer with an integer, or a float with a float. So we will need to concatenate our area, which happens to be an integer in this case. 51 into 10, it's going to be 510, which happens to be an integer. So we need to convert it into a string to be able to display it to the user. str, this is the concatenation function, just like we use int in the length and breadth inputting of the variables from the user. Str of this area, and very nicely it displays area of rectangle is 510. So that's really cool, and this is the first step towards learning programming, maybe programming in Python or maybe programming in any other language. So now that we are aware of what is the kernel and how it allows us to interact with the user very interactively, now let's learn something about the script window. So here in the script window, we just push in some code. We can create a new file. From file, new file. You can just push in some code like print hello world, and you can save this file. From save, give it a name, say hello new .py. .py is the subscript for the Python files, which we need to include so that our operating system or our computer is aware that we are coding in Python. Okay, so we save it. This button on the top below run, it allows us to run the file. We can also use a shortcut on our keyboard, which is F5, to run the Python script we have coded in. After typing run, in line 16 you can see this location of the file where this script is stored, and hello world, this is the output of the script. So now that we know about basic things in Python, it's time to know more about the variable types in Python. So as I said, the types can be an integer. You have a number 24, it's an integer. The type can be a float, 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 like decimal point truncated with 24.5, it's a float. The type can be a string, say hello world, it's a string. Oops, we can store it in a string underscore new is equal to hello world. The type can be a boolean, bool, bool, bool. It shows the type is a boolean, either a true or a false. True means 1, false means 0 in terms of digital electronics. And the type can be basically anything amongst these types or a combination of the other types. So there is a provision in Python, there is an inbuilt function called type, which allows us to see what's the type of the variable. Say we have a variable, we can create a new variable, a is equal to 5. We want to see the type of this variable. Clearly this is an int, but let's see how a kernel shows this is an int. Type of a, press enter, you can see it's an int. Similarly, we have a string underscore new created on line 20 of the kernel, hello world. Clearly it's a string. Just type of string underscore new, and you can clearly see that it's a string type. Great. We can create a floating point variable, fl underscore new is equal to 24.503. Type of fl underscore new, and it shows a float. Nice. Create a boolean variable, bool underscore new is equal to true. Type of bool underscore new, bool. Bool means a boolean, either a true or a false. Okay, so these are the variable types in Python. So now that we are aware of the variable types, we can jump into something a little more complicated, which is conditionals. What is conditionals? It means we can have our computer make decisions. We can make our computer more intelligent by giving it the provision to take decisions on its own. And this is achieved by what we know as if, else, and elif conditions in Python. So suppose that we want to just check whether a number is even or odd. So we can just use our script window here. Though, so this is the code to check whether a number is even or not. We can use the hash symbol to uh, add a comment. It is nice to add comments because the comment wouldn't be executed by our IDE. It wouldn't be executed by our compiler and an interpreter, but it will help us know in the near future what we are doing in the code. So program to decide whether even or odd number. First we are going to take an input from a user of a number which we want to check whether it's even or odd. Suppose the number is stored in a variable num. Num is equal to, it's going to be an integer, so we need to typecast it using int, convert it into an int. Similarly, like we did for taking the length and breadth as input for the rectangle, input, enter a number. We have executed this num is equal to the command to input the number. Now the important part comes for the conditional. We need to check whether the number is even or odd. So what is an even number? 2, 4, 6, 8, 10, and so on. You can clearly see that even number is a number which is divisible by 2. So when a number is divisible by 2, what does that mean? That means the remainder when divided by 2 will be 0. So here comes the interesting part. We have learned about the modulus operator or the percentage operator, which gives us the remainder when a number a is divided by another number b. So we can just use that operator to make our decision. And how to make decisions in Python? Using the if else clause. If, just type in if num %2 is equal to 0. It means when the number when divided by 2, it gives us the remainder equal to 0. Just take note of this double equal to. It's the comparison operator. It's not the equal to operator. The single equal to operator, it is an assignment. When we assign something to a variable, like we were doing it in the kernel here, like we were assigning a is equal to 5 on line 21 here, or string underscore new is equal to hello underscore world. It's an assignment, single equal to, but for checking comparison, it's a double equal to. So if number when divided by 2 gives us the remainder 0, just print that the number is even. So use the print number is even. But if this condition is not true, what to do? Obviously, if a number is not even, that then it's going to be odd. So just type in else. This is the else clause in Python. Else print number is odd. And thus we are done with this code. A simple code to check whether a number is even or odd. Save this code, even underscore odd dot py, and run it from this button here. It asks us for a number. Say we enter 8. Number is even. Cool. Again give it a try for an odd number. Enter a number. Say 13. Number is odd. Really nice. So this is the if else clause in Python. There is another case, what to do if a thing happens or there is another condition present in our code. It is known as the elif condition. Elif. So let's do silly code here to just learn about elif. uh, we are going to ask the user for a number. Say num is equal to, so if the number is, we are going to add a condition. If the number is less than, this is the less than operator. If the number is less than 5, print less than 5. else if elif the number is greater than 5 and number is less than 10. This and is a logical operator. There are various logical operators we'll see later. And means if number is greater than 5 and less than 10, means it lies between 5 and 10. We just print between 5 and 10. Else print number greater than 10. Obviously, if a number is not less than 5, if a number is not between 5 to 10, it is going to be greater than 10. So we display it to the save this code and we run it. It asks us for a number 15. Great, it's greater than 10. Another thing, enter a number, say -3. Clearly the number is less than 5 and it displays so very rightly. So now that we know about conditionals, it's time to learn about another concept which is known as control statements and iterations in Python. Now, what to do if we want to repeat a sequence of code again and again? Suppose you want to print a multiplication table of 2, or suppose you just want to make a nice game of maze, lost in the maze. So how do we do this? So let's learn more about this. Let's create a new file. So suppose we want to execute a code to print the multiplication table of a number. Suppose multiplication table of 5. So we first define a number, say num is equal to 5. We have a concept in Python which is known as for loop. For loop helps us achieve the purpose of repeating a sequence of code again and again until a particular condition is met. So it's done by typing in for. We define a new variable for I in. There is a function in Python called range. Range means what's the maximum limitation on the number. For suppose for I in range 11, the range function works from a range a to a minus 1, b minus 1. So suppose this is 11. We want to print the multiplication table from say 5 times 1 till 5 times 10. So we give it a range 1. This 1 is inclusive to 11, because if we give it 11 here, it is going to run till 10th value of I is equal to 10. So this loop is going to run from I is equal to 1 till I is equal to 10. We simply print, oh oops, so we simply store it in a variable which is the result. Res is equal to num times I, and just print it. We will give a new line so that it looks appealing. We print a new line and then simply print res, which is the result. Okay, so run this code. Multiply underscore new dot py. Oops, so in this range function we don't give a colon, we give a comma. So okay, for I in range 1 to 11, which means I runs from 1 to 10, print the multiplication table. We run this code. So here you can see 5, 10, 15, 20 till 50. So it prints the multiplication table of 5 by repeating the code sequence till the condition I is equal to 10, which means till I is in the range of 10, the code runs. And once this code is once this condition is fulfilled, the code ends. We can just check this thing right here. So if we print in ended here, it prints ended. But think about it, what to do when we want to print in. So we need to take care of one thing here in Python, which is the indentation. If we indent things just wrongly, if we don't do it right, then it is going to give us serious errors. Suppose instead of typing print ended here, I had just typed it here. What do you think will happen? Yeah, you were right. Ended is going to print 10 times till the loop runs, because ended becomes a part of this code sequence, and it's repeated again and again until I comes down to the range of 10, which is the last value. So we need to take care of indentation. Now what we have done here is using a for loop, and the same thing can be achieved using another thing in Python, which is known as the while loop. Its sequence, the coding sequence is a bit different, but the results will be very much same. So to try the while loop, the first thing here is that we need to give a number initial value before we begin the while loop. We need to check the condition in the while loop, and when the while loop condition is met, then we need to increment the variable or decrement the variable, unless and until we wish to give an infinite loop, and our computer will just hang if we don't give a condition to the loop, because anything we write therein, it will repeat again and again billions of times. So first we give an initial value to a number. Suppose we have a number is equal to 5. I want to display the multiplication table of 5 using the while loop. Okay, so give the initial counter variable just like we had done in the for loop. We give it an initial value just before beginning the while loop, a value 1, because we want to display the multiplication table starting at 1, 5 times 1 till 5 times 10. So here we begin the while loop while I is less than equal to 10. When I is less than or equal to 10, we store the result in a variable res is equal to num times I, and we just print out res. But wait, is this the end of the code? No, we are just initializing our variable I to 1, but we are not changing its value. We want to print the multiplication table from 5 times 1 till 5 times 10. But how to change this value of I from 1 to 10? We need to increment it each time this code is executed. Now, after the value has been put in the print variable, we need to increment I is equal to I plus 1. And this is how the code will work. First, we have the number 5. Initial value of I is equal to 1. It will check is 1 less than 10 or equal to 10. It's right, true. Then it will simply it will store the value res is equal to 5 into 1, which is 5, and it will print 5. I will be incremented from 1 to 2. Again the loop will start at the line 14, which is while is 2 less than 10 equal to 10. It's true. It will again run, then 5 times 2 will be 10, and it will just display the result, right? So just to make sure that the code looks much appealing, we print a new line before displaying our result. We run the code. Okay, so in this code we have forgotten to put a colon here. After the while loop, after the for loop, after the if statement, else statement, elif clause, we need to put a colon just to show our IDE that it's the beginning of a conditional statement or a control statement. So just run the code. So very nicely it displays the table of 5 from 5 times 1 till 5 times 10, and achieves the same goal as the for loop, right? So now let's do something a bit more interesting. Suppose we want to create a maze game using the while loop. And how the game works: if the user moves left, then the game displays that user is lost. And until and unless the user types in right, the word right, then the game will end, or the user will be out of the maze. So this is a maze game. Suppose we take in a direction from the user. Direction is equal to input, which direction to move, left or right. User will type in the direction, either left or right. It will be stored in dir, while dir is not equal to right. Until and unless user types left, what will happen? We just print you are lost in the maze. So this will keep on happening again and again until and unless the user types in the string right. Okay, so we just save this code, maze underscore game dot py. Okay, but one thing, we need to take the input from the user again and again, isn't it so? If we just take an input from the user once, whether you want to move left or right, or suppose the user types in left, the left is stored in dir, the while loop will go again and again, and it will turn into an infinite loop. So let's see what's wrong in this code here. Just run this code. User types in left. Oops, sorry, we need to type in a string with the quotes. User types in left. The code shows that it is a string input to the compiler, and here you can see this keeps on going again and again. You are lost in the maze, and you are lost in the maze, and this is an infinite loop. To terminate or abort the loop, uh, just our computer will simply hang through this bad piece of code. Just press Ctrl C on your keyboard, and on pressing Ctrl C, we will come out of this loop, and we will resume our normal operation. Okay, so this was just a bad piece of code to show you what happens if we don't put in dir input into this loop. So we need to put this into this loop. Okay, so the game keeps on asking the user which direction to move, left or right, and unless the user keys in right, it tells you are lost in the maze. And if the user presses left, it comes out of the loop. And what to show when the user comes out of the loop? We just print you are out of the maze, congrats. Cool. So we run this code piece of code again. Which direction to move? Let's say we move left. It shows you are lost in the maze. Suppose I type in left again shows you are lost in the maze. Now suppose I type in right, you are out of the maze, congrats. But here there is a glitch. You see that here it shows you are lost in the maze again, and then it shows you are out of the maze. So how do we avoid this glitch? We can avoid this glitch by putting our print function on the top of this input. So what happens? This display will not be called because it's on top of the dir input, and when the user types in right, it will simply move out of the loop and it will print you are out of the maze. So let's run it again. And now after we have moved the print function up here, let us give an initial value to our direction. Suppose it is dir is equal to left, which is the condition when the person is lost in the maze. And if the person exits this loop, then it shows print You are out of the maze. Congrats. Cool. Run this code. Which direction? Suppose I type in left. Lost in the maze. Again left. Lost in the maze. Now let's type in right. You are out of the maze. Congrats. So it's really nice. Our code achieves what we wanted to do. Maybe this was a bit more complicated than the earlier version of the code, but yes, it's really nice. And if we keep on thinking about this thing for 5 to 10 minutes, then we are going to surely understand it. And you can try your own manipulations, you can change things, you can make additions, you can make manipulations to better understand this piece of code. So this was just a beginning to Python, an introduction to Python. There are many more things to learn, which I'm sure that you can explore on your own. And even I am thinking of putting such videos on the internet for educational purposes. And I hope you like this video. Thank you.